Hi, my name is Jason Harlow. Welcome to my V Office Hour. I'm going to go over my solution for Physics 132H1F Fall 2009 Test 2. This is version 1, problem 7, and it's based on Knight Physics for Scientists and Engineers, 2nd edition, Chapter 32, Fundamentals of Circuits, and in particular Resistors Circuits, which is section 32.7. So first, let's carefully read over the question. What is the current being drawn through the battery of the circuit shown? So here's a circuit. We've got a 12-volt battery. So the current comes out of there, hits a junction, where it can either go down through a 15-ohm resistor or over to the right through first a 10-ohm resistor, down and around through another 10-ohm resistor. Then it comes to another junction where it joins back up with the current that went through the 15-ohm resistor. Then it goes to the left and up through a 4-ohm resistor and back to the battery. And our choices are 0.31 amps, 0.95 amps, 1.5 amps, 4.4 amps, or 6.2 amps. Okay, so on page 976 there is an equation for the equivalent resistance of n resistors in series. That is 32.17. It's the sum of all the individual resistances. And then if you look at page 980, equation 32.26, it gives the equivalent resistance of n resistors hooked in parallel. And it's the sum of all the reciprocals and the reciprocal of that. So our strategy here is to step by step reduce the circuit to the smallest possible number of equivalent resistors. So let's take a look at my solution. Okay, so taking a look at my solutions, we're going to break this whole circuit down by looking at these parts and trying to separate them all. So I've redrawn it over here. The first thing to notice is that these two 10-ohm resistors are in series. So you can draw the whole circuit equivalent to this, and you see that 10 plus 10 is 20. So this circuit is equivalent to this circuit. 12-volt battery, there's a 4 ohms over here, and now we have a 15-ohm and a 20-ohm in parallel. So we add the reciprocals and take the reciprocal of that, and this circuit is now equivalent to this. This is 8.57 ohms in series with this 4-ohm resistor. So adding these up, 4 plus 8.57 is, this circuit is equivalent to this, 12.57 ohms, just hooked up to a 12-volt battery. So this is now a simple circuit, and the Ohm's law is IR. And so we have voltage of 12 divided by equivalent resistance of 12.57. We end up with 0.95 amperes, so the answer is B. So it takes a little practice, but you don't always need to be applying Kirchhoff's loop law and Kirchhoff's junction law for circuits, especially when there's only one battery. It's basically taking sets of the resistors that are either in parallel or in series and reducing them in complexity till you work your way back to the battery and get a simple circuit. So that worked for that one. My name is Jason Harlow, and I approve this message.